All right, so I'm going to share you a new link where we are going live. Is that okay?
Yeah, yeah. Sounds good. Five, nice. I can share it too.
Okay. So that's the new link. Let me just tweet it. Let me just tweet the new link so that people can view us live from there.
Yeah, yeah, perfect. Perfect. Yeah, it's coming through on mine. So I'll also put it here.
Hello, Jacob. So I
Hello.
just want us just to do 5 minutes. I just want to do a 5 minutes broadcast. We're going to be starting in 5 minutes, so I just want to do a 5 minutes broadcast with the new link.
Okay. Sounds good. Sounds good.
Okay, so I just want to do a quick tweet um, of the new link.
Okay. Let's do it.
All right, so we have 6 people watching us right now. All right, hello guys. We are so glad and excited to have you all. Please, we're going to be starting this in a couple of seconds from now. We would love to have you all. We would love to have you all share this um, new streaming link on your social media, your platforms, and your friends, just to tell them that um, we are live now. We are live now. We are just to this. There was a bit of an issue, so um, please give me a thumbs up. Give me a thumbs up if you can hear me. If you can hear me live, please give me a thumbs up. All right.
Awesome.
All right. So let's just do this. Let's share the link. In 5 minutes, we begin um, this awesome session on RoboFlow. Yeah.
To have everyone. And yeah, as Alicia said, feel free to share the link with everyone in your network, and we'll have a great session here. Really looking forward to it.
Awesome, awesome. I can see very awesome comments here and there. Oh, cool, cool. All right, so in 3 minutes we should go. We should begin the session. All right, guys. I'm so glad to welcome you all, and I'm so excited. Okay. My name is Odemakinde Elisha. Just a bit about myself. Um, I'm a researcher at Data Science Nigeria, and uh, of course, a lot of you guys know me to be community, you know, community at Data Science Nigeria. We handle community there. All right, so just a quick one. I'm so excited to host everyone here, and I'm so excited to also have Jacob here, and I will just be sharing a little insights into the reason why we are actually having this session. Please, as we move on with this session, I would love to have chatting from the WhatsApp and from the YouTube chat section. I would love us to talk about this RoboFlow of a thing. As Jacob is dishing out those, punchlines, I would love us to just be responding with our comments because I'm watching you guys also. I'm also on YouTube seeing everything. I'm going to be seeing a lot of your interactions and discussions, your questions. Everything will be duly noted. We are going to be answering all those questions. So I just want you guys to be calm. Just try your best, ask the questions that try ask the questions and of all those questions. All right. So just a quick one about myself. Of course, I work with Data Science Nigeria as a researcher and more importantly as a community manager. So I have Jacob with me here. Jacob is actually a machine learning engineer at roboflow.ai. What actually caused us having this meeting is because of the fact that there was a time I was just trying to think of I was thinking of doing something more than image classification. Like I just wanted to just work something relating to I wanted to do something real time. So and I was thinking, okay, let me get this done this way, let me get this done this way. Then I was thinking, okay, let me just do, and then I came across the roboflow.ai platform, and I discovered it was very, very fascinating and wholesome. In the way it was it was very, very direct in putting you how to do computer vision, and that's the reason why I'm to sharing this great opportunity with everyone that is watching us live, because it's not going to make a lot of sense if I only a lot of you guys must have heard of roboflow.ai, but quite a lot of people from community they do not know. So that's the reason why I'm like bringing this up to you guys, that no, we have to just have something wholesome. We have to have we have to in action. And that's the reason why I had to, mail Jacob. Of course, I was in contact with Jacob via the Slack channel, and we began talking about some things relating to object detection and um, computer vision. And because of that, I was just so excited to just say, okay, Jacob, let's just do this. Let's just do this. A lot of people want to see this great idea. They want to see this awesome intentions. They want to see this awesome work that roboflow.ai is doing to ease computer vision in end to end. And that was what pushed me to actually writing about roboflow.ai. To actually writing about the articles that you guys have been reading on Medium. So I wrote an article on hand-to-hand detection with end-to-end object detection with efficient threads, which was an object detection architecture. I'm sure a lot of you guys must have read it. When I released out the video, a lot of you guys were like, "This is awesome, this is cool," you know. So I was like, no, for people to be so excited to see something like this, then let us introduce to them the end-to-end platform that gets this done for them in few seconds. That's the reason why we're having this session. So I'm more than excited to actually invite Jacob, and I'm so excited, Brad and then Joseph also, they were able to accept um, my willingness to have Jacob on this platform. So Jacob, I would just love you to just say a few things about yourself before we actually go into the deal of the day.
Sure. So first
All
of
right.
all, this is an immense honor to be here and to be able to speak with you all. This really is kind of the embodiment of the mission of RoboFlow, which is to make computer vision easier for any developer to use anywhere in the world. So the fact that we are seeing traction, with people starting to deploy these technologies anywhere in the world, including Nigeria, exciting fact for me. So very excited to be talking about this and gotta give you guys a little bit more info about RoboFlow today. A little bit about my, I've gotten interested in AI over the years, and I was working actually originally in the market, trying to predict stock prices were moving and things like this. And then I started working building NLP chatbots and virtual assistants. And came across this opportunity to join some longtime friends of mine on the Roboflow project. So they've been working on Roboflow for over a year now. I've been here for about 5 months, and we are really excited about the growth that we've seen and the product that we've been able to build. I primarily work on the machine learning side, which is kind of and working on the technologies underlying training computer vision models, and also working on our product to kind of try to make it even easier to get to that moment where you went from just having raw images to that moment where you see a model doing inference, which is sort of similar to the experience that Alicia is talking about with using efficient det to detect objects and object detection. So that's a little bit about me, and really looking forward to diving in deeper.
Oh, awesome, awesome, awesome. That's actually the spirit, and that's actually, one of the most important reasons why I'm like, no, we just have to bring this down here. You know, I was like, when I was thinking about to get a lot of things done, and I came across this your platform, and it made a lot of things very easy for me, to doing a lot of computer vision tasks and projects that I've been engaging myself in, and that's the reason why we are having this session. All right, so guys, I know we are more than excited to actually have Jacob to start the session. So you guys have heard a little about him. But before I go ahead, I just want to just share my screen and then just point out a few things that I want you guys to do. I want us to tweet, and I want us to use the following um, hashtags on our social medias. So let me just share my screen in a couple of seconds. All right. So all right, guys. So I want to believe you guys can actually see this. So I want us to follow roboflow.ai on Twitter. Yeah, use this. I want us to follow roboflow.ai on Twitter. Tweet your experience about roboflow.ai, what you've been learning, what you'll be learning from Jacob, the live session and the live demo and everything. I want you to use that at roboflow.ai, hashtag computer vision, hashtag AI, and hashtag Roboflow AI. All right, so I will now be handing over to Jacob. I'll be handing over to Jacob to start the session. So Jacob, over to you. Thank you.
All right, guys.
You
now
can share your screen right now to make your presentation and then start your live demo. Thank you very much.
Sure. Yeah, so I'm going to share my screen, and let's see if we can get both of us up here. See both of us here in the corner. So yeah, everybody can see everything okay? Okay for you, Alicia?
Yeah, it's okay. It's okay.
Okay, great. Okay, great. Okay, so awesome. So here I'm going to kind of dive in and give you a little bit of just a of what the mission of Roboflow is and what we're sort of working on doing day to day. So basically, we're starting with the mission of taking raw images and transforming them into a trained computer vision model. So here, this is an example of some boats and houses that we took pictures of via a drone, and then we were able to pass them through a computer vision model that could now understand how to label things like boats, houses, and docks, even without ever having seen the test images before. So that's a little bit on Roboflow. So Roboflow builds developer tools that enable any developer to use computer vision. So it's a really good way to just kind of get started if you're just starting to dabble in computer vision and you want to try to get from images to getting your model off the ground very quickly by loading in your data and doing some conversions on your data, some augmentations on your data, and then exporting your data over to a training environment. And then you're able to kind of also share your data and your models via the Roboflow platform. And we're going to dive in a little bit deeper on all that in a demo later. But this is just kind of the broad idea of what Roboflow is doing with conversion and analysis. Okay, so this is sort of a exciting time to be getting into computer vision. The technologies are just starting to get good enough, like with the release of papers like Efficient Debt, which allows basically anyone to kind of pick up a model architecture and then apply it to their problem and already see really great results. And because this is a unique time in kind of human history with computer vision becoming more applicable to all sorts of different industries, we're basically seeing like a Cambrian explosion of computer vision apps coming out all over the world. For an example, here we've put some fields that we've seen coming through the Roboflow through our notifications of people. So we've seen people using Roboflow to detect weeds in fields. So if you're flying a drone over and taking pictures of the field, or you have equipment that you want to spray weeds with, people are actually kind of identifying what's a normal plant and what's a weed. There are people who are looking at pipes where they see a pipe and there is gas leaking out of the pipe, and the computer vision model is able to kind of sit over top of the pipe and see where these leaks are, and then kind of automatically alert those who are running the pipeline that they might into this area, which is very important for things like environmental regulation and kind of making sure that systems are safe. We have measuring fish, actually measuring the number of up a river and kind of counting salmon migrations as they're up through the river. One other interesting area is a hard hat detection. So this is where people are kind of trying to determine if someone has a hard hat in or not. And this is really good for compliance and keeping people safe. And so that's just a few examples, but I think you kind of get the idea basically that anything you have in your head that you think is sort of a replicatable image that sort of tell the semantic difference between objects quite easily, and you think you can construct that into a data set, and then you train a computer vision model, that idea that you're having is probably actually pretty well founded. And getting started with a tool like Roboflow or anywhere else with computer vision technologies is a great way to get started and just kind of see if the thing that you are is actually feasible. And it's sort of for a fun example here, we actually have one person building an application to identify different kinds of sushi. So as the sushi is coming through on a little conveyor belt in their restaurant, they're identifying what type it is, and then they're able to eat different kinds of, or they're able to identify different kinds of sushi for the customer. So that's just a few examples that thousands of developers are coming through Roboflow and using computer vision for different technologies. But certainly this is a movement that's much broader than us. But I think, I guess here we just have some proof that all of these, and if you have an idea of using something, then I certainly recommend getting started and reaching out and kind of getting some traction on it. So now I'm going to talk a little bit about, since this is a data science meetup, we're going to kind of get a little bit more in depth on exactly what the process looks like to go from your images to the model. So basically, this is kind of the way that we see things, which is there's a few main steps. So you'll have your images and you'll need to gather them. But then once you have a data set of images, you want to label these. So this is the labeling step where basically you're providing annotations to the computer to be able to understand what exactly you're trying to teach it to do. So the thing you usually start off with is classification, which is just kind of like making a distinction between if this is an image of one thing or another thing. So you could say, I recently trained a classification model to tell whether a flower is a daisy or a dandelion. And that's sort of like the basic level. Then there's other types of labeling you can do where you can actually draw a box around the object that you want to detect, and that's called object detection. That is a little bit more popular, and a lot of people are using that for a few reasons, because you can count actually the number of things in the image, and then you can also localize objects in the image. And then that's kind of a little bit more exactly like the way that humans see. And then going even further is there's a modeling technique called semantic segmentation, where you're actually drawing lines and outlines around objects. So that's kind of more even getting closer to the way that we actually see things, which is via outlines. But in any event, you'll make labels your data set, and then these will be your annotations, which are sort of informing the computer as to what things it should be paying attention to and what things it should be learning to model. And there are a few solutions there. There's all sorts of open source free solutions, which are things that I recommend, like CVAT or VOT CVAT and VOT and label image. These are all free things that you can just you can start labeling your images for free. I'll provide some links there for those as well. And we have a lot of content on the Roboflow blog of how to label. But then there's other solutions, like if you want automatic labeling, you can use Amazon Mechanical Turk, or for really big projects, you can use Scale AI. Anyways, there's all these labeling services, and all of them, whatever the data format is, it can be exported, which is something that we're very big about supporting. And we make sure that you can ingest your data in any format it came from. And better yet, Roboflow actually has a lot of public data sets that are already labeled. So you can just kind of go ahead and lift off the data set that you found and sort of get started right away with something that's already been constructed. Especially if you just want to learn about the technology, I highly recommend just kind of taking a public data set labeled and sort of using it to just get a feel for the technology. Then the next step in the computer line is to organize your data. So you can imagine the first time you go through, it's pretty easy to just kind of have one data set, and you'll just be kind of pushing that data set through the process and no problems. But at the end of the day, running a ton of these different experiments, you're going to be wanting to images here, rotate images here, or you're going to want to actually not try to model this class. And going to be all kinds of different branches that your data can take. And it's important to kind of keep that process in an organized fashion. Another thing that Roboflow helps you do is you can kind of version your data, and you can be organizing it in kind of all in a clean fashion, which experiments you're going to next. Of course, all that kind of done outside Roboflow via folder structures and such, but this is just kind of one tool where we are trying to add some value in the pipeline. Then after you kind of have your data organized, you can process it. So process incorporates two distinct things here. The first one is the pre-processing step. So pre-processing is some sort of image transformation that you're going to make that's going to span your whole data set. So across your train sets. This is something that you're doing to kind of standardize your data to basically remove some elements that you want to kind of simplify your model or simplify one example here would be probably the most common example here is the simple resize step. So you might want to make a smaller model by resizing your image down. And if you're doing an easy task, then resizing down is going to be a really good way to kind of make a smaller model and just send in a smaller image. But that's an example of a pre-processing step. Another example of a pre-processing step might be to use a static crop. So you're then for a static crop, you would be actually cutting out just a small box. And because you know that the object that you want to be focusing on is always in the same spot. So that's going to apply to all images, and it's just something that you kind of take for granted as a standardization step across the whole data set. The other kind of processing that we allow you to do in Roboflow is dataset augmentation. And augmentation is something that only applies to your training set, so only to the images you're going to be showing your model. And it allows you to generate more training images from the base images. So this is where you're kind of trying to think, I have this data set and I want to try to think ahead of problems that my model might be having in advance. And I'm going to kind of sniff these out by thinking about ways that I can transform the base images that I have into a way that will sort of model the future and sort of anticipate the way that the things that the model is going to be struggling with in the future. So for example, if you're making an application to model receipts, so you want to be able to cut out little boxes out of a receipt, you might be zooming in or zooming out with the picture you're taking. So it would make sense then to zoom your images in and out. And this would be, we could do this via a random crop. So the random crop augmentation kind of can kind of crop your images randomly or widen them out, which is simulating the zoom effect. A lot of more advanced augmentations like mosaic data augmentation, where you can do clever things that it's sort of like kind of, it's more so sort of addressing problems in the way that the model is memorizing things. Like, so mosaic augmentation takes an image and it tiles it into 4 different tiles, and then stitches all those tiles together, and then kind of makes a new image out of 4 different images. And what that does is it sort of teaches your model to localize in different spots, because your objects might kind of all be localized in a single spot and be memorizing that location. So that's an example, another advanced example of augmentation. These are all things you can do in Roboflow and you can do with Python libraries to sort of make your data set even bigger. So now we've gotten through the first 3 steps, and after that, you want to be starting to move into the modeling process. So this is actually where the machine learning comes in, and I'm sure a lot of people here are really experienced with getting hands-on with machine learning models, and we'll be really excited about this step. But sort of the hard part is done. You've gotten your data set into the spot you want, and now you want to get it through into a model. So where you can do this, there's MakeML, there's PyTorch, there's TensorFlow, and just like the way that Roboflow will ingest any labeling tool that you have or wherever your data set comes from, it will also export to any training environment that you might have. And this removes a very tedious step in which you often have data in one spot, but you want to get it to another. And so you have to do all these complex data transformations, even though at the end of the day, the underlying semantics of a bounding box or a classification label is the same. But you want to make sure that the data is transformed into the right format, so then you can send it through into whatever the training pipeline that you want to start training. So during training, the model will be the feedback that you're giving it via the images, and it will be using gradient descent to backpropagate through its parameters to start learning kind of the structure of the thing you're trying to teach it. So that's the training step, and I'll show a little bit more on that on the via the Roboflow model library and the Roboflow Train features here in a minute. Then after you've trained your model, this is where things can often get a little bit more complicated too, is deploying it. So the blog post that Alicia was mentioning was where he trained an efficient model here in the train step, and then he went over to deploy it onto a Raspberry Pi. So this is where you're taking a model that you've built and you're actually bringing it into real life by putting it onto a device. And that is where a lot of people actually spend their time, where they're actually just working on just taking a trained model and putting on deploy and seeing how fast they can get it to run. And a big thing here, a big concept is real time. So the way the human eye sees is at so many frames a second, and people are trying to get that to the exact level that it seems like the model is actually detecting things in real time. But deploy is a very important step, and it's kind of what ends up bringing your model to life. And then once you're there, you actually display the results via however you want. Maybe you're just tracking things in a database, or you're displaying them on an app. The next step is that's on to you. So this is where kind of Roboflow sits in helping the developer push their way through the computer vision pipeline. But at the end of the day, the developer will be kind of seeing the whole landscape here and making their own application and coming up with their own usage for the technology. So that's a little bit on the computer vision pipeline. I know I covered a ton of ground throughout that whole process there. So feel free to drop some questions in the chat, and we can kind of zone in on your own individual interests on that step down the road. So I know I keep talking about examples of applications, but this is a little of what the Roboflow founders were able to do with computer vision. So they were originally interested in augmented reality. So here's an example of Magic Sudoku, where that kind of can scan over a Sudoku board, automatically identify what numbers are in it, and then send that into the solver. So if you've ever seen Sudoku, this is kind of a cool augmented example of how to do it. I was going to talk a little bit about computer vision modeling, the train step here, because this is kind of my personal interest. So as you're doing all that data management part, that's all that's designed here to create the right thing to pass through your network. So this is an example of a network where the images are being passed through convolutional layers, and they're forming features based on the underlying image. And then there's a whole kind of downstream modeling process where all these are being mixed together, and then the prediction is coming out at the end. So it's important here to think like this is a pretty complex process, and you really want to make sure you get this original input step right before moving forward. And that's going to really help you out. So a little bit of a pause, see Alicia, if you have any thoughts, and then we'll a Roboflow live demo.
Cool. So let's just wait for a moment. You want to take some questions? Is that what you want, Jacob?
Yeah, sure. This could be a good time to take some questions.
Okay. So let us just have questions from you guys. Let's have some few questions from you guys before we go live with the demo. All right, guys. So questions. Okay. So if there is no question, then we might just have to. I think it's because the thing is a bit lagging behind. That's the reason why we haven't had our responses.
Oh yeah, that makes sense. Yeah, I know there's a couple minute delay. Yeah, so I did see actually I did see one interesting question come through a little bit earlier. So I see someone asked, that I started as a quant, and why did I switch? So this is good. This is good. I think at the end of the day, I was very much interested in quant finance because it was a really complex problem, and I got to use a lot of interesting technologies, and it was a good way to make money for a little bit. But at the end of the day, I wasn't super fulfilled with the work, and I wasn't really felt like I was building anything for the world. It was just kind of like you make an application, you spin it up, it's up there, and then you don't really see any of the impact. So the fact that Roboflow is kind of already reaching corners of places like Nigeria and stuff is like something that really gets me motivated, and like that we're actually computer vision is something that's actually going to transform the world. And I think working on it is a really good thing for humanity to just kind of move forward with technology and build new things and make the world a better place. So ultimately, that's kind of why I jumped ship. And honestly, I think on the tech side, a lot of the problems you'll encounter are just as interesting. So that's my 2 cents on that topic.
Okay, awesome. Jacob, so we are having some interesting questions popping up from my screen over here. So somebody is asking, okay. For you that you asked today, Omidola, I hope there will be a video for us to watch later. Yes, it's always available on YouTube on this channel. Um, okay, so somebody asked, can you use RoboFlow to detect moving objects?
Yeah, so Roboflow allows you to do, so you can kind of detect each object in each frame. But that is actually a good point of sort of getting a sense for the same object being localized. And I will say that that's an area that I would say we probably are able to help in the data pre-processing and augmentation aspect. But being able to localize the same object involves models that I personally haven't started to get acquainted to yet, but always be curious to hear more about the project and what you end up finding with it.
Awesome, awesome. So I hope that actually answers the question. Um, RoboFlow is actually used for, you can use it for moving objects. All right, so another person asked, I'm wondering how transfer learning fits into this. I have a small labeled data I want to fine tune on. Okay, I think that's an incomplete question. If I could rephrase it, it's trying to ask how you can use transfer learning using RoboFlow for is small data, is
Yeah,
small data.
definitely,
All right,
definitely.
so Jacob, would you want to answer that question? I don't want to answer any question for you, Jacob. I'm not going to answer any questions for you. So you're
Okay.
just going to do this yourself. Okay, so what's going to be the answer regarding that?
Yeah, so on the transfer learning front, um, Roboflow does certainly help you use transfer learning. So as you're making your original data set, you are kind of tuning into a certain area that you want to be modeling. And then a lot of our tutorials on modeling will show you how when you take your images, you can send them through to train based on a pre-trained network. So most of the networks you'll leverage, especially in object detection, will be they'll be pre-trained on the COCO data set, which has over 200,000 images or with 80 classes. So this is kind of designed to teach the computer how to just identify sort of any small feature in an image, and then after the computer sort of learned to identify those basic features, and then you apply it to your own data set, you'll see good results. So yeah, and then furthermore, if you want to be transfer learning
Oh,
from, you can actually kind of, if you start to have a ton of experiments, then you can transfer learn from checkpoints. Like maybe you already have a aerial satellite imagery checkpoint where you're kind of like, you already have started a lot of different experiments there, and you can start from that spot. So definitely good to look ahead on transfer learning. It's definitely an advanced technique, but I think it's super important.
a quick one. We are going to just ask two more questions so that we can go into the live, demo session, because that's actually the most important part. That's actually the most important part. So I'm just going to take the next two questions. Somebody said, how useful is RoboFlow in finance? How useful is RoboFlow in finance?
Oh yeah. So I haven't done anything on that. We have some people who are like processing receipts and stuff. So they're doing kind of like the back end like sort of processing of documents and financial documents and such by identifying portions of text and then sending that into a OCR type app. But other than that, I don't know. I guess the application is sort of up to you. I know there are some people who use computer vision to like estimate how heavy or light an oil tanker is as it's crossing the ocean. So it's like you're actually kind of getting an idea for flows of oil, and then you can make trades based on that. But I don't know. It's up to you.
Yeah. Actually, it's a generic question. Actually, it depends on the aspect of what exactly in finance. It depends exactly on what exactly in finance you want to do that for. I would basically say more of OCR actually, but let's just quickly take this last question. All right, he said for a non-Python developer to pick up Roboflow to use for predicting production level in a manufacturing company. That's a very, very important question, and I really want you to answer that question.
Yeah. So
I think you
honestly,
saw that question, or should I repeat it?
oh yeah, I heard it. The non-Python applications.
Okay, awesome.
Yeah. Yeah. So
Yeah.
that is a question actually that's sort of very top of mind for us these days, which is as I go through a live demo here, you'll see we have this data management platform, which is all no code. It's kind of you're up on the application and you're able to click through things. And then we would traditionally kind of funnel the data into a Python type environment where you could start modeling things on your own. So a new feature that we worked on is sort of automatic training. So you can take your data and use Roboflow to just one click automatically train your model, and then you have it up on an API endpoint where you can pass images through via command line or no JavaScript or whatever you're developing in. So that's a feature we're really excited about rolling out here in the next couple of weeks. But there is early access, so you can always reach out to me, and we can always try to get started on the app. But yeah, we do have a few manufacturing examples where people are just hitting the API and they didn't write any Python code to train it. They're just kind of leveraging a trained model.
Exactly. Train modules. That's almost the easiest way to do. In fact, the one I did, other detection, efficient debts on peppers and onions. It was exactly pre-trained modules. It's not going to be very easy, training from scratch and all those things. All right, so Jacob, I will want us to go into the live demo right now. So all other questions. I'm seeing a lot of exciting questions coming up on my screen over here. But there are things that we can answer after the live session. Of course, they would see the live session and they would have answers by the time they see the live session. All right, so can we begin the live session?
Sure. Here, I will pull it up. Yep. Okay. Let's see. Sorry. 1 second. Okay.
Okay.
You guys can see here?
Yeah.
Okay, great.
Yeah.
So if you want to get started, I mean, if you're at your desktop here, you can actually go ahead and go to roboflow.com, and we can sort of do a little bit of an example here. But yeah, so this is roboflow.com. We say transform raw images into a trained computer vision model in minutes. I think minutes is a little bit fast, but so that's the idea. It's supposed to be quick to get there. But so I'll go ahead and just sign in. And when you log in, you'll see a screen here. And the screen basically is sort of like your command center for your data. So you have your data sets, and they're all here. There's different versions of things. So here we have tires and chess pieces and phones and such. Those are the things that I've been clinking away on over the last couple of days. But you get in, and so what you can do is to get started, you can just hit create a data set. So here I'll create a chess sample for YouTube with annotation class pieces. And then the other thing here is to decide what kind of data set it is. So object detection is the most common, which is what mostly is coming through, which is just kind of the bounding boxes. You can choose to just classify your images or segment them, or there's the types we were talking about, but we'll do object detection here. And then you go ahead and hit create data set. And then this is the upload flow. So this is the area here where Roboflow developers have made it super easy to just kind of bring in whatever data set type you have. So here, for example, I might have this chess sample, and it's here. There's example images. So there's an image of a chess set, and then here's the labels. So these could be in whatever format. Kind of doesn't exactly matter, but you can bring your data set in any format. So you can just go ahead and drag and drop your data set in there. This is all in the onboarding flow too. So you can kind of get started. We like to use chess as an example because there's all the chess AI links. So here we'll kind of use the chess set to sort of get a feel for the way that things are working. So here's a new preview. We just put in these new previews we're really excited about, where you can see your different classes. So, and then after your data is loaded in, you can go ahead and hit finish upload, and then you have an opportunity here to split between train, valid, and test. So the train set's going to be what we show to our model to learn from. The validation set's going to be what we check. We check our model with each iteration to see kind of how well it's doing, and then the test set is the thing we hold out for the very, very end to evaluate on and really make sure that the model did a good job of modeling on our test images. So there we go. Then that go ahead and that uploads it up into the Roboflow cloud. So one thing I should mention here is Roboflow is free for the first 1,000 images, and so you can kind of be getting a feel for using it for projects, and oftentimes that's going to be plenty of time to get started with your or that's going to be plenty of images to get started with whatever your project is, because the models are getting better and better now, so they're able to learn very quickly. So once your data set is loaded in, you'll see it here, and it will be kind of in this data set version page. And so this is, again, where you can kind of just get a feel for like, oh, did I get my images in the correct fashion? Are they here? Are the class labels all here? And you can sort of do some data set introspection there. The other thing I really like to use is this data set health check. So this basically lets you see how many images, what are the classes. So makes sense for chess, right? That the pawns are the most common, and then going down the line with different pieces. And then the other thing you can see is the annotation heat map, which shows you the localizations of your object. So I found this to be useful sometimes if the model is like unable to identify an object in a given spot, then that shows me that I should gather some data that's a little bit more varied or in different places. And yeah, and so that's kind of it for the dataset health check. And then back into the modify stages. This is what I was talking about in the processing step for computer vision, where you're trying to take your images and you're processing them ahead of time. So pre-processing is sort of the first thing, where you can do those things like I was talking about, like static crop, or you can do like a tiling. This is something that can also be useful, or you can modify your classes. So maybe I want to rename or only export certain classes, you can do that here. And then the other side of the processing is the augmentation step. So this is the part where you're actually making transformations to your images. So you can flip things like this, or you can rotate them like so. You know, you can be making kind of, like I said, trying to see ahead to problems that your model is going to be having as it's modeling things, and making those augmentations to make your training set even bigger. So this is where you kind of decide how many multiplications you want. So you can go up to like 50 generated images per normal image. So then once you're ready to go to make your new version, you just hit generate images, and that basically goes through, and this is going to just send that processing job to our backend, and all these cloud servers will be spinning up and doing all kinds of different things, especially if you have a big data set. And you just don't even have to think about all that stuff. It just kind of shoots out. Yeah, so then the big thing here is the exporting. So this was what I said is really useful, is like some people actually just use Roboflow just as a conversion tool. So they'll come in with one data set annotation type, and then they'll come out via a different one. So these are all the ones we can export to. I'll go ahead and click YOLO Darknet here. And so this gives you zip or download code of where to get your data. So this here is kind of an example of behind the scenes of like kind of where you would go if you wanted to actually start modeling and start doing experimentations yourself. You could take this link and go forward, as we will here as we continue to go with the live demo. But otherwise, you know, the thing I was talking about is this Roboflow Train, which is something I've been working on pretty heavily lately, which is to just kind of spin up a GPU on the cloud, load in your data set, do all the training, and post the endpoint without having to go through all of that yourself. But certainly there's different cases here where, like, if you want to be using Roboflow more hands-on for all your different experimentations and such to get a really good feel for computer vision modeling on your own, then you want to go through the export route. But yeah, so here we can see we have some different versions going on with our data, and now we have a data set that's been transformed in these ways. Yeah, so now you're ready to move out of the Roboflow platform and into modeling. I guess before we go into that, one last thing on the dataset side, which I want to show you guys, is this public datasets link. So this is something you can get started with without even gathering your own data. So this is the blood cell detection data set, which I use in a lot of different tutorials, and I think it's a really good way to kind of get started with things. So public data sets, you can go ahead and just grab one of these and just sort of get going on this next step without even having to gather your own images. Yeah, so the other thing I want to show you guys is this Roboflow Model Zoo. So this is our model library, which is I think a really cool place to get started. I know Alicia and I are working on adding a better version of this because I wrote this one, but this one's not so good. But here you have all kinds of different models where you can deploy things. So the classification, if you're doing classification right now, I think this ResNet 34 is a really good one to use. Otherwise, this Yellow V5 is a really good one to use. This is object detection. And so we'll have a few things. We have a video where you can see us kind of going through it in video, as we're going to be sort of showing here. There's also the Colab notebook, which is a really good place to get started. So you can just kind of jump over to the code. So yeah, so this is an example notebook here where we're in Colab, which is Google's providing us free GPUs. which is really nice. And you can kind of just log in there. And so, this whole process, like I said, just getting started doesn't cost you anything. It's just a resource out there to start familiarizing with the technology and get started. But yeah, so I'm not actually going to run through this, run the code, but I'll just kind of go quickly through the steps here so we can kind of go from the theory I was talking about earlier into how it actually manifests itself in a real training job. So here we'll just take a peek at the GPU. So this is what Google Colab provides you for free, which is pretty exciting. So that's the GPU coming in. And then here we're using Darknet, which is where the YOLO model came out of. So this is a very popular small object detection model that runs really fast. So any notebook you're going to have is going to start with a step like this, where you're like kind of installing dependencies and you're building things. And hopefully Roboflow's gotten the code right so this doesn't break. And so you can just kind of move forward without having to redo it. But we also have our support Slack if you have any questions on that. And then here's the step where Roboflow comes in. So you can download your data set in, and it's coming down. And here are all the images. This was from the public blood cell set that I was talking about. So now your images are coming in, they're loaded into your computer, and you want to tell the computer where the files are, points the files to the images, and then this part you're like making the network. So this stuff is usually, you don't have to edit it, but you can later if you want to get into the weeds. Yeah, so you build the network, you load in the images, and then here's the network actually printed out. And then you get down to this step and you're like, okay, so I got these images, I got this network defined. I'm going to run the training job and I'm going to start passing those images through the network and start training it. You watch here as the loss goes down and your model's starting to learn and you're getting excited and you can bring in more images later. So that's the training step. And then once it's done training, then you can actually use it. So you can be in the notebook here doing a little research and you're like, okay, so now I'm going to pass an image through for inference. So this is an example of an image that the model has never seen, but it was trained to understand these objects. So it knows what a red blood cell is, it knows what a platelet is, and it knows what a white blood cell is now, just by being shown training images. We don't have to install OpenCV and do a bunch of complicated color matchings to get these things. It's just learned from the data. So that's a good way to get started, I think. And you can export there. You can run it on video. You can run it on webcam, and then kind of build applications around it. So yeah, that's an example of getting started. Sort of through the Roboflow suite of technologies and things that we have available for you guys. So we can keep the discussion going. Oh,
that's really, really
you're on mute
awesome.
there for a second.
Yeah, I did. Okay, so wow. I'm seeing some in um okay. All right, but guys, before we go ahead to answer a lot of questions from you guys, I said something from the start of this program. It's very, very important. Let me go ahead to share my screen. It's very, very important, guys. I want you guys to I want you guys to I want you guys to tweet at roboflow.ai. I want you guys to use the hashtag computer vision, hashtag AI, hashtag roboflow AI. I really want us to, see you guys do this. Do that. Let's do that. Let's do that. All right. So, yeah. let's go ahead to have questions. So, Jacob, we have some questions here, and I'm sure a lot of them should have answers by now. Um, okay, the first answer says, can RoboFlow? Okay, you've answered the first. Okay, now the one I want you to answer, the first one I want you to answer is, can RoboFlow handle prediction streams directly?
Yes, yeah. So that's sort of in the, so after your model's been trained on the images, then you can run the model through a video stream and you'll see the predictions coming out of it. So, but obviously that's like once you get to that step and you have the model ready to go, then that's kind of where the work comes in into being able to run it in real time and such. But that's yeah, super important step.
Okay, okay. I think the person is more or less like asking if, you know, who has this everything you need into developing computer vision model, whereby you have you passing you can do your preprocessing, you can export your data in terms of the XML files, the object detection aspect, you can do classification, semantic segmentation in Roboflow, and a lot of things like that. So the person is more or less like more specific in the sense that, is there, after doing all of these things, such that you've been able to export the model, train, is there more or less like can just pass in the real time, the image, and then you get a result in real time.
Yeah.
So instead of
So
you going so instead of actually going through the routes I went in my article that I wrote last week. So
mm-hmm.
I had to do all the pre-processing in Roboflow, export the data, then load them into Google Colab. I exported it as a link, so load it into Colab, did the training on Colab, and then exported the model reference from Colab. Then I was able to
Yeah,
now
yeah.
put it on export it as a TensorFlow Lite, put it on the Raspberry Pi. So it's more or less like, instead of you going through the route of just extracting the data from Roboflow platform, just do the training of the data directly on Roboflow, do the such that you're just going to have an API key. You call the API key, you pass in the data, and then you get a result in real time without having to write code.
Yeah.
Is that possible?
I wish. So the possibility is at like a 2-second lag now for an image. So yeah, so we have it now, so you can auto train, publish the API point, have the key, and then send an in an image. But for real time video, that is still something we gotta do the export onto device and do sort of like what you did with TensorFlow Lite. So hopefully, as technology advances, we'll be able to get there. But right now, we're still kind of stuck on that point, and it's definitely an area of like intensive effort and trying to learn how to do it better.
Hmm. Awesome, awesome. So I think that answers the question from one of our. So the next question I would love you to answer is, can RoboFlow be used in medical fields, more diagnosis of disease? Actually, you've answered that in the video, but I would love you to shed more light on that, so that I'm sure this person is going to be medically inclined in applying
Mm.
a computer vision to doing that. I would love you to shed more light regarding that.
Yeah. So I have a few use cases that have come up, are immediately coming to mind. So we have of the blood cell detection. So you can pass microscopic images through computer vision models and use RoboFlow to train models to understand cells and microscopic images. There have been some people who have used it in identifying like different wound types, things like that. And then another use case is like counting pills. So people kind of have made an app where you can just kind of look over the pill, see them, and then sort of are are what. So those are just a few things that come to mind. But I would say um, think about something that's easily replicatable and is something that you can collect the data set on, and then that might be a use case. But is sort of up to your imagination, I think. Yeah.
Mm, yeah, exactly. So I hope that for this question. Another person, regarding having access to Jacob. Okay, how do you do that? Um, Jacob's going to be the answer regarding that. How to okay, right?
Yep. Yeah. LinkedIn will
Hello,
be
Jacob.
good. Yep. Oh, can you hear me?
Okay. So guys, yeah, I can hear you. I can hear you. So I think, guys, you would you can check out Jacob on LinkedIn. I don't know. Jacob isn't on Twitter yet. Isn't on Twitter yet. So maybe very soon he's
Yeah.
going to be on Twitter. Whereby
I'm
you guys
not.
can decide him. But you can actually reach him. You can reach him out on. You can reach him out on LinkedIn. Jacob Flowers. All right. So I think that's okay, right? Jacob,
Yep.
that's okay.
Yep. Yeah, I put my link there in the chat too. So look forward to talking with all of you guys there.
Okay, so let me just, okay, I think it's on the live chat. Okay, I will drop it over there right now. But let us answer the next question. The next question says, in finance, how can it be used to fraud? How can Roboflow be used in detecting fraudulent transactions in finance? Is that really possible?
Hmm. That's interesting.
That's going to be a big question to answer.
Yeah, that to me that sounds a little bit more like an NLP question, or maybe a different machine learning model, like a time series of transactions and such. So I don't think vision would be the way to go. But maybe if you have some ideas, there might be ways to use it there.
Oh, okay. All right, so guys, to connect with Jacob on LinkedIn, here is the link. So you can message him, link up with him via LinkedIn. All right. So regarding that question, I don't think you can actually use. It's not going to be that simple, unless you just want to. Unless I think it's actually going to be you can NLP, but it's going to be more or less like the normal data science classification, prediction, whereby you have data from that. There was even a time I kind of built a model relating to that, but it's just going to be. I don't think it's going to really be computer vision. It's not really going to be computer vision in this case. All right, so guys, um, another question for Jacob. The person says, can it be used in an environmental issue? If yes, I'm interested in learning this. Please, how? Like, how can RoboFlow be used for environmental issues? That's kind of a bit big question actually. But let's know your opinion.
So the question was to use Roboflow for environmental issues to
Yeah,
improve the
environmental
environment.
problems and yeah.
Nice. So I just keep jumping back to use cases here, but we had one person on the app using it to identify plastic bottles that are floating in a river. So you are kind of like building some sort of cleaning structure that like identifies the plastic bottles and goes and sweeps them up. But yeah, I think the leak detection was another big thing that we've seen, where like if you can see these oil leaks or see these gas leaks before they become bad, then that can be a really big improvement for the environment. I would think anything that involves like surveillance or something that to do with sort of monitoring the environment that you think you could incorporate computer vision into would be the way to get started. But again, sort of up to the imagination, the developer to conquer the task.
Oh, yeah. Actually, I would really want to say that's actually the best. Surveillance and the likes. That's actually one way to apply Roboflow to that. All right. So says um, nice tutorial. Quick question: after training the model on the Roboflow API, can the model be saved on a local computer and be used for future projects, or is it only restricted to Roboflow web?
Yeah. Okay. So
You get
the
that? Jacob, did
yes,
you get that?
yeah. So the automatic training is restricted to the web for now. Um, if we were to launch into a business venture together, we could try to figure out ways to pull it out of there. But otherwise, the way to get the models sort of exported for yourself is through training them in the Colab notebooks, and then you get a weights link, and you can kind of take and transform it into wherever you want to bring it on the device. But we're thinking about working on that to make it so it's something where you can export. The only thing as a which would make sense as a business is we don't really know how to monitor usage or anything yet with model exportation, but we'll figure it out. So yeah.
Okay. All right. So we're almost drawing closer to the end of the session, but let me just quickly take this question. There's a question coming here. It says, when will Roboflow AI models, when will Roboflow AI models optimized for edge computing be available, that is to run on resource constrained microcontrollers? Did you get that, or should I?
Yeah, I got it. Yeah, that's a good question.
Hello,
So
Jacob?
we're
Should I repeat that?
oh yeah, I got it. But yeah, no, we're working on making the models exportable into all sorts of areas. But depending on your particular use case, I'm not sure if they exist yet, but they run well on small edge devices like there's vision processing units from Intel, so like the NCS, and they run there on OpenVINO. And then also like Raspberry Pi. And then you can use the also small NVIDIA like Jetsons to run them on their normal environments like PyTorch and such. So I'm not sure on your particular hardware, but definitely people are working to make these things run faster and faster on all sorts of different devices.
Okay. I think the ones you were trying to refer to just now, the VPUs, the vision processing unit, and the like that you just mentioned, um, like the FPGAs and the likes, by Intel, those ones are they kind of have more compute powers. So I think the question is much more directed to microcontrollers, uh, which one would I want to say? I don't want to call Arduino in this case, I don't want to call Arduino.
Hmm.
Microcontrollers like PICs and the likes. Is it possible?
Yeah,
Like, is it really possible? I haven't tried it yet, but I would just want to recommend the use of, the Intel videos and the likes, SDKs into actually
mhm,
doing this. But I'm not really sure if it could work on microcontrollers because these models are
mm,
quite a bit heavy. They are quite a bit heavy unless they have been hosted online, such that you call the APIs to fetch the model and then pass in the
mm,
real time whatever to the microcontroller. So the microcontroller is just going to be more like an interface trying to control those things. But nonetheless, I still think the RAM is also a key factor in determining the compute power because not all models are even there's going to be a limitation. Even if you are running TensorFlow lights to do all these things, there's still going to be a limitation whereby you still have to consider the RAM of the microcontroller you're trying to use. If the RAM is very small, you still have the cache of the model of the microcontroller, and if the cache is not if it is not huge enough to take the or load the model for real-time processing, I don't think it's going to work on microcontrollers, but I think it's a bit feasible. It's something one will want to try, use our hands on. All right. So another question I would love to. Okay. Okay. Yeah. 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 Okay. Can it work on ARM? I think it can. Well, of course, Raspberry Pi. It should. It should. If it's Raspberry Pi, it should be able to. All right. So Jacob, do you have? I think that would be all the questions for now. Jacob, do you have anything you would want to say before we give the final conclusion to all of this?
yeah. Just thanks for showing up, guys. This has been a real pleasure to be able to talk about computer vision with you all. And feel free to check out Roboflow and good luck on your path with computer vision. And look forward to seeing what you build.
Okay, awesome. All right, so guys, before we call it a day, I want to share you this. I would love to have you guys fill this feedback form. We want to know how you feel regarding this webinar regarding computer vision with Roboflow AI. This is actually an eye-opening to how to do your computer vision stuffs, without so much coding with roboflow.ai, But of course, please, we do love feedbacks. We do love feedbacks. Please fill the form and let us know how you feel or what you feel regarding roboflow.ai because it's going to really help us in planning forthcoming webinars like this. All right, tweeting because I can only see few tweets. Of course, I can see some people tweeting, but the number of people seeing us here are really more than that. And I really want to encourage you guys to please tweet, give us feedbacks, like tweeting, please do that so that we can know how you feel and let us trend on Twitter. All right, so finally, I want to appreciate the Roboflow team, Joseph, Brad, Jacob, for making this possible, for releasing Jacob to having an awesome session with us. It hasn't been easy, like really, really, it hasn't been easy. A lot of checkpoints, try this, let's check this, let's correct this, let's work this, let's do this, So guys, please, before I just complete my text or whatever, please fill this feedback for because Jacob is kind of planning to have another one whereby we're going to have a more hands-on session whereby people are going to be taught this thing live, but it's going to be virtual, live but virtual. This is just a scratch on the surface just to make you guys see the whole process. So, but I want you guys to feel the feedback from it's going to really help us in planning that live session on how you can use robot function applications and development. All right, so finally, I want to thank everyone for joining, and I also want to thank I want to thank Digital Science Nigeria for giving me uh, the go ahead to have this session, because without them this session wouldn't have been possible. All right, so guys, please tweet your free tweets and let us know you, and more importantly, fill this feedback form. Thank you for joining us. Say before we call it a day, before we end the session.
Yeah, no, that's it. Thanks so much, guys, and we'll see you out there on the web.
All right, thank you guys. All right, stay calm, stay safe, and do enjoy your ride. Bye, guys.
All right, see you guys.